All right, this is Math 2, Worksheet 2. These are the solutions to numbers 20 through 27. Mr. Trutna from Clovis High School. Did you know the first French fries were not cooked in France? They were cooked in Greece. All right, remember, smash that like button as you watch this. And let's get started. Okay, all right, so number 20. What we're going to do in this problem is, in 20 through 23, we're going to simplify. We're going to leave our answer in simplified radical form when necessary, and then all variables represent positive numbers. Okay, so let me zoom in a little bit so it might be a little bit easier to see. Okay, so here we go. So getting started. So the first thing that we do whenever we're simplifying this problem is called a rational expression, and the reason why it's called a rational expression is because we have a fraction for an exponent. Okay, so one thing that we want you to remember is that whenever you see, and you don't see it in this problem, but you will see it, whenever you see the term rational expression, all that is saying is, that is a fancy way for saying that we are going to have an exponent with a fraction. Okay, like number 20. We have an exponent, it's a fraction, it's 1/2. So there's going to be a certain process that we do when we have these type of problems in order to simplify. And the first step in this process is that you will rewrite the problem as a radical. Okay? So you're going to take the denominator of the exponent, which is 2. You're going to make that the index. Then you're going to take the base of the exponent, which is 25x squared. You're going to make what we call the radicand. And then the radicand is going to have an exponent, and it's going to be whatever the numerator is, which is 1. Okay, so rewriting this in radical form. Now, keep in mind that when you rewrite it in radical form, you do not have to put the exponent of 2, and you do not, or the index of 2, excuse me, and you do not have to put the exponent of 1. Okay, so that's always going to be our first step in simplifying. Then we're going to take the radicand, and the radicand is this part right here, and we are going to make a factor tree out of the radicand. So we're going to factor 25x squared. 25 factors into 5 times 5. X squared factors into x times x. And so the next step in simplifying would be that you take the radical that you have and you rewrite the radicand in its factored form. 5 times 5 times x times x. Okay? And then after you do that, now you're going to take a look at the index, which we already determined is a 2, and you are going to you're going to be looking for 2 identical numbers, like 5 and 5, or 2 identical variables like x and x, and whatever you have identical, those will go to the outside. So you will have a 5 that gets moved to the outside of your radical, and you will have an x that gets moved to the outside of your radical. And then you're going to multiply those values together. So when I simplify this problem, I have a 5x on the outside, and then if you have no leftovers after you identify your identical numbers, then what that means is that your final solution is just what's on the outside. So number 20 would simplify into 5x. Okay, number 21, we have an exponent of 1/2. So to simplify this, the first step is I'm going to rewrite this problem in radical form. Okay, my exponent, or my exponent's denominator is 2. That will become the index. My base of the exponent, which is 8x to the 4th, that will become my radicand. And then that radicand will have an exponent of 1. Okay, I don't have to write the index of 2. I don't have to write the exponent of 1. All right, now I'm going to take my radicand, which is 8x to the 4th, and I'm going to make a factor tree. 8 factors into 4 times 2. 2 is prime. 4 factors into 2 times 2, so I factor 8 into nothing but prime numbers, and the product of 8 would be 2 times 2 times 2. I'm also going to factor x to the 4th, and that would just factor into x times x times x times x. Okay, so now what I do is I take my radical and I rewrite it in its factored form. So 8 becomes 2 times 2 times 2 times x to the 4th is x times x times x times x. Now what I do is, when I simplify this problem, I look at my index, which is a 2. I determined that from over here, and then I'm going to find 2 identical numbers. And every time I find 2 identical numbers, I'm going to move them to the outside. So you can see I have 2 identical numbers of 2's, so I'm going to move that 2 to the outside. I have 2 identical x's, so I'm going to move that x to the outside. I have another set of 2 identical x's, so I'm going to move those x's to the outside, which I mean that I have x squared. Okay, and then my final answer is going to be multiply what you have on the outside, which would multiply to 2x squared, and then if you have any leftovers, and I do in this case, the leftovers stay underneath the radical. So I would have to keep the radical because I have a leftover, and the 2 would stay underneath it. So number 21 simplifies into 2x squared square root 2. Okay, moving on to number 22, I have 2 to the 3/4 power times 2 to the 5/4 power. Now, if you have multiple bases, like you have in number 22, before you try to simplify it by turning it into a radical, you first want to rewrite the problem so that there's only one base. So in order to do that, I'm going to use what's known as the product rule. The product rule says you keep the base, which is 2, for multiplication, and then you add the exponents together. So you're going to add the 3/4 and the 5/4 together. You want to do this because you want to have your problem having only one base. Now, this particular problem is going to work out nice and neat for us, because if you notice, 3/4 plus 5/4 becomes 8/4. 8/4 simplifies to 2. So this problem, I don't have to change it into a radical in order to simplify it, and the reason is because 2 to the 4th power is just equal to 4. Okay, so in number 22, by adding the 2 exponents together, that's called the product rule, keeping the bases 2, the problem simplified out to 4. Okay, number 23, if you notice, I have a base of 3 with an exponent of 1/5. I'm multiplying it by a base of 3 with an exponent of 3/10. So in order to simplify this, I first want to combine the 2 problems together in order to just have one base. So I'm going to use the product rule, which says keep the bases of whatever they are because they're the same, and then you add the exponents together. So I'm going to add 1/5 to 3/10. Okay, now I cannot add those 2 fractions together until I have a common denominator. So in order to get a common denominator, I'm going to have to change 2/5 or 1/5 into 2/10. So I'm multiplying by 2 over 2. 2 times 1 is 2, 2 times 5 is 10. And then I'm going to add that to 3/10. Now I can add the fractions together, and that gives me 3 to the 5/10 power. I can reduce 5/10 power into 1/2. Okay, now we could try to simplify this problem by turning it into a radical. So when I turn this problem into a radical, it would become, I would have the radical, I would take the 3 and make it the radicand, I would take the 1 and make it the power of 3, but I don't have to write a 1, and I would take the 2 and make it the index, but I don't have to write the 2 there. Okay, and then I would take my radicand, which is 3, and I would make a factor tree of it. Well, you cannot make a factor tree of 3 because 3 is already prime. So that means this problem is simplified. All right, I have a 2 here, so that I would need 2 identical numbers to simplify. That's impossible for me to do. So your answer to number 23 would be either one of those. Okay, now since the instructions said, if we go back up here, it says leave the answer in simplified radical form. The simplified radical form would be the part of the answer that's in the radical form, so the square root of 3. Okay, number 24. We're going to number 24 through 27, we're going to simplify, and we're going to leave the answer in simplified radical form when necessary. Okay, so doing number 24, just like I did 22 and 23, I want to make the problem so I have just one base. So I'm going to keep the base of 5, and then I'm going to add the 2 exponents together. Okay, now I cannot add fractions together until I have a common denominator. So the common denominator between 6 and 4 is going to be 12. So I'm going to change both of the fractions so that they have a denominator of 12 so I can add them together. You would multiply 6 by 2 to make 12, so you would multiply 1 by 2. 2 over 12. You would multiply 4 times 3 to make 12, so you would multiply that 1 times 3, so I get 2 twelfths plus 3 twelfths, which would give me 5 to the 5 twelfths. Okay, putting this into radical form, I would rewrite the problem as a radical. My 5 here would become my base, would become my radicand. That 5 would become the exponent for 5, my radicand, and that 12 would become my index. Okay, now this would be my answer. I cannot simplify this any further, and the reason is because 5 to the 5th power means that I have 5 5s. But in order to simplify, I would need 12 identical numbers. Okay, number 25. I have 7 to the 1/2 power. I have to change this next radical into exponent form. So that would change to 7 to the 3/2 power. Okay, so if you have if you're asked to simplify and one problem is in exponential form, and the other part of the problem is in radical form, first thing you want to do is change them both into exponential form. And now we're going to combine these together by using the product rule into one base. So what I'm going to have to do is I'm going to add the exponents together. Keep the base of 7, add the exponents together. 3/2 plus 1/2 is 4/2. 4/2 reduces to just 2. 7 to the 2nd power turns my simplified answer into 49. Number 26. Once again, I have an exponential form. I'm multiplying it by a radical form. So when this happens, you first want to change both of the problems into exponential form. So the second part of the problem would become 3 to the 2/3 power, and then we would use the product rule and rewrite this problem as having just one base. And how I would do that is I would keep the base and add the exponents. Okay, I cannot add those two exponents together because they do not have a common denominator. So before I can add them, I have to change that 3 into a 9. And I'm going to do that by multiplying by 3, both the numerator and the denominator. So I get 2/9 plus 6/9, and then I add those up and I get 3 to the 8/9 power. Okay, now I rewrite this problem in radical form. So in radical form, I would have my radical symbol. My base of 3 becomes my radicand. My 8 becomes my exponent for my radicand. My 9 becomes the index. And now that would be my simplified answer. Okay, And I know that's simplified because 3 to the 8th power would mean that I have 3 times 3 times 3 times 3 times itself 8 times, but the only way I can simplify it is if I can come up with 9 identical numbers, and I would only have 8 3's, so I cannot get 9 identical numbers, so there's my answer to number 26. Okay, number 27, probably the trickiest problem of the last part, 20 through 27. So the way you have to think about number 27 is we know that it's in radical form, okay, and I want to see, is this problem actually simplified? Now what's weird about it is I'm going to have to convert it into exponential form first. So really, if I thought about it this way, that x to the 1/4 power is actually to the 1st power. So if I rewrote this in exponential form, I would take my radicand, which is x to the 1/4 power, and then I would raise it to the exponent of 1/5 power. Okay, all I'm doing is I'm changing my problem from radical form into exponential form. Okay, now I'm going to simplify this by multiplying the two exponents together. 1/4 times 1/5, 1 times 1 is 1, 5 times 4 is 20, so this problem simplifies to x to the 1/20th power. Then I'm going to convert this back into radical form. So I'm going to put the radical, the base x will become my radicand, the 1 will become my exponent for my radicand, I don't need to write that, and the 20 will become my index. So that is your simplified version of number 27 in simplified radical form.